Hi everyone, I am presenting my Kafka-based real-time order processing system developed using Java, Spring Boot, Apache Kafka, and Avro. This system supports real-time order streaming, retry logic, dead letter queue handling, and live price aggregation. Now I will start with the project structure and explain each important file and its function. This is the root project directory containing configuration, source files, and supporting resources. Under the POM XML file, it defines project dependencies such as Spring Boot, Kafka, Avro, and Confluent schema registry. In the Docker Compose YML file is used to spin up Kafka, Zookeeper, and schema registry using Docker. It ensures all the required services work in containers for easy setup. Then we will go to see the main Java file of this application, that is the Kafka order system application. It contains the main method that launches the embedded Tomcat server and initializes the Kafka consumers and producers. And under the configuration files, the Kafka topic config file defines all Kafka topics such as orders, order entry, order retry, and orders DLQ. It ensures that the topics are created automatically when the application starts. Under the Kafka consumer config file, it contains configurations for Kafka consumer such as bootstrap server, group ID, deserializers, and error handling logic. Under the controller, it has the order controller file. This controller exposes REST APIs for producing orders and retrieving live statistics. It connects the outside world with Kafka producer services. Under the services, it has four main service files. First one as the order producer service. This service sends order data to Kafka topic using Avro serialization. It handles order publishing to Kafka. Then the order consumer service file. This service consumes message streams from Kafka topics and it implements retry logic and forwards failed messages to the dead letter queue. And under the price aggregation service file, this service calculates real-time order statistics like total price, total orders, running average, like things. Under the DLQ monitor service, this service monitors the dead letter queue and logs failed orders for debugging and auditing. The application YML file under the resources contains application configurations like Kafka server address, topic names, schema registry URLs, and consumer group ID. And under the Avro order file, this is the Avro schema file defining the structure of the order messages. It ensures type safety and compatibility during Kafka messaging. So this is the system that includes a REST API client, Kafka producer, Kafka broker, Kafka consumer, retry topic, dead letter topic, and aggregation service. When an order is sent through REST API, it goes into the Kafka topic. And if processing fails, it retries up to 3 times before moving to the dead letter queue. Here, it retries up to 3 times before moving to the dead letter queue. Now, let's move to the live demonstration. First of all, we got the service and connect the Docker. Then after that, it seems like Docker Compose, like this my project name Kafka order system. Then in here, or by using the Docker Compose YML file, we can run all the services like Zookeeper, Kafka and schema registry. I will start from here. Then you can see all the services are started. And also here it shows it very clearly. And after that, the next step is we have to run the main file, that is the main Java file. That's Kafka order system application in my project. We can run that file using here. Here you can see it runs successfully. Then after that, this runs successfully, and after that we will go to the terminal and get a new file, and we will first create 20 random orders by using this command. You can see it starts to producing successfully. Here also you can see those are start to processing. The order processing is now over. Then again we can see, get those statistics by using this command. In there we can get the total orders, total price, running average and failed orders. In here you can see some orders are failed and then they send to retry queue. Likewise, this is handling. If any order is failed to process, then it sent to retry queue. Then again it start to process. Likewise, the orders are processing successfully. And also you can see the Kafka topics by using this command. The topics are these orders, orders DLQ, orders retry. So this project successfully implements a Kafka streaming system with Avro serialization, retry logic, dead letter queue, and real-time aggregation using Spring Boot. Then after that, all are finishing, we will stop all these services. This is my Kafka order system project. Thank you for your cooperation.